Hello students, myself is Parminder Singh from Prab Kripa classes. Our today's topic is Introduction to Histogram and Frequency Polygon. In our earlier courses, we have learnt that data is of two types, that is primary data and secondary data. Primary data is the original data which is collected by us, that is where we ourselves are involved in collecting the data, and we can collect the data by way of surveys, experiments, observations, etc. On the other hand, the secondary data is the data where the work has been done by some other person and the same has been published somewhere, that is we can get the secondary data in the form of news reports, TV reports, government records, books, magazines, or from the digital records. After the collection of the data, we have to present the data so that the said data can be used for the purpose for which it was collected, or the data can be used for decision making. And to present the data, we can make use of ungrouped frequency distribution tables or grouped frequency distribution tables. We can also make use of bars, bar graphs, or some other forms. Now, here we will discuss that we can also represent the data in the form of histograms and frequency polygon. We will understand in this course that in the case of histogram, we make graphical representation of the data in the form of bar graph, where we form the bars which are adjacent to each other and there is no space left in between them. We will also understand that the frequency polygon is that where the data has to be represented in the form of a curved line, and the curved line connects the midpoint of each class interval. We will also understand that in the case of frequency polygon, it is not necessary that the class interval has to be in the form of continuous data. However, the frequency polygon is mostly used in the case of continuous data. Now, after going through this course, the students will understand that if the length of some leaves of plant is measured and the data is represented by a table having discontinuous class intervals, then how to draw a histogram for that data? That is how we can form the histogram when the data is of discontinuous class interval. We will also understand that whether the data which is used to draw histogram can be used to draw any other suitable graph. We will also understand that if the data in respect of lifetimes some neon lamps is given in the form of a table, then how to represent the information with the help of histogram. The students will also understand that if the table shows distribution of students in two sections according to the marks obtained by them, then how to use the data to form two frequency polygons on the same graph. You will find this course very useful and informative and very easy. Now the question before us is the length of 40 leaves of a plant is measured correctly to 1 millimeter and the obtained data is represented in the following table. This is the table where the length of 40 leaves which have been measured is given. That is, here it is given that the 3 leaves are such which have the length in between 1018 to 126 millimeter. There are 12 leaves out of 40 which have the length in between 145 to 153 and so on. That is, the length varies and the number of leaves also varies. Here we have been asked to draw a histogram to represent the given data. Here a hint has been also given. First, make the class intervals continuous. What it means? Here you will observe from the data that here the group is 118 to 126 and the next starts from 1 to 7. That there is a difference of 1 between these two groups or these two class intervals. In the next case also there is a difference of 135 and the next starts from 136. And in the case of next also there is a difference of 1. The continuous data means that data, if we say that from 112 to 126 and the next data starts from say 126, and in the same case if the next data starts from 135, then there is continuity in the data. There is no gap in between these any two class intervals. There is no gap. This is the continuous data. So now the hint which has been given to us that first we have to make these class intervals continuous. That is, there should be no gap in this upper limit of the class, this class interval, and the lower class limit of this class interval should be the same. That is, this entry should be the same with this entry should be the same with this. How it happens, we will now discuss the same. Now first we will learn what is the meaning of histogram. Histogram is the graphical representation of the data. What data? Which is continuous in nature. Histogram is the graphical representation of continuous data. How we are to represent this data? In the form of bar graphs, where there is no space between the graphs. That is, when we are forming the graph, each graph will be adjacent to the another. Now we have been asked to make the class interval continuous. How we can form the same? The data given here is discontinuous. That is, after 1 to 6 it is 1 to 7. This here is given is discontinuous. That is, the class intervals are discontinuous. So To draw the histogram, we have to make the data continuous, because as you have already learned from the definition of histogram, it is the graphical representation of continuous data. So here, as the data has been given in discontinuous class intervals, and to draw the histogram, we have to make data continuous. So how we can make this data continuous? To make the data continuous, you will see that there is difference of, you find that there is difference of or gap of 1. You can see that 126 to 127 1, 135 to 136 gap of 1, 144 to 145, each class interval has a gap of 1. That there is a difference of or gap of 1 in each class interval. In every class interval there is a gap of 1. So we will subtract half of 1, that is 0.5 from lower class limit that is from 118 we will deduct 0.5 and add 0.5 to what? Upper class limit. So we will go on doing this. We will subtract 0.5 from the lower class limit in each class interval and add 0.5 in the upper class interval, upper class limit. So it will go on. So the table comes so when we have done all this, what will be the shape or how the table will appear? We will form the same. Serial number, length, number of leaves. Here we will draw 7 serial number 1, 2, 3, 4, 5, 6 and 7. 1, 2, 3, 4, 5, 6 and 7. So what will be the first case? When we deduct half, it will become 117.5 to 126.5. Next 127. As the data will become continuous, it will be come here. So now 135 we will add 0.5. This item will appear again here because we will reduce 136 by 0.5. 135.5 to here we will add 0.5. 144.5. Now 145, we will subtract 0.5, it will become 144.5. Then 153, it will become 153.5 because 0.5 will be added. It will be again come here because we will reduce or subtract 0.5 from this figure, and the next will be 162.5 because here 0.5 is added. Here 163.5 is deducted, or here this item will come. Here 171, here we will add 0.5. Here 172, we will deduct 0.5 and it will become 171.5. Here 180, we will add 0.5. So the number of leaves are to remain the same. 3, 5, 9, 12, 5, 9, 12, 5, 4, 2, 5, 4, 2. So here you can see from the table which has been formed now that here the data has become continuous, that 126.5, 126.5, 135.5, 135.5, 17.1, 171.5, 171.5. That is the data has continuous data. This is the continuous data. There is no gap in between any class interval. So the class interval have become continuous. Now we come to the next point. Now we are to form the histogram. How we will form the histogram? As we have told that here we are to represent the data in the form of graphs, and the graphs are here to be not to be separated but adjacent to each other. This is the x-axis, this is y-axis. Now what you can see that what is changing here, we can take length here below and the number of leaves are to be taken on this side. Number of leaves, what is being taken on the x-axis? It is length in millimeter. What is this? We have mentioned wrongly that when we are to mention the length, it will be from 117.5 to 126.5 in respect of the first class interval. So here after some distance we have to mention the kink. Kink means that up to this data it means 117.5. There has to be kink, just like in thermometer that it does not, that the temperature does not go below. Here we are mentioning the kink, that we assume that this distance is 117.5 in millimeter. Now we take the equal distance as, say, up to this point. Up to this point we assume that this is 180, which covers this, say, 2 points, 2 cells. So it is 1 to 6.5. From this point to this point we take it, represent, this is the x-axis. So here 117 to 126.5, here the number of leaves are mentioned. We will take it from on this side, 1, 2, we have to mention 12, 3, 4, 5, 6. After every 2 cells we are marking one cell, one leaf, 8, 9, 10, 11, 12. So on the y-axis, we have marked the number of leaves, and now we will be marking length of each class interval. 112, 117 to 16. This is the, then the number of leaves are 3. So here it will be up to this point. So this is the first class interval which we have mentioned here. So the leaves are 3. Next is 1 to 6.13.5. So as we will take equal width. So here it is 135.5, which represents this point. You can also write in such a way that there is no problem in reading the same. So here it will come here. You have to connect this. You are not to leave any space between two bars. These are all adjoining because the data is continuous. Here the number of leaves are 5. The next will be 9. Here we have to leave 2 cells so that we can mark 144 point. You can also write in this way 144.5. As in the exam, you can rotate the answer sheet, you can mark it properly, but we cannot do so here. Then it is 9. 9 comes up to this point. So here it will be up this. You have to draw straight lines while you are marking the lines. Here it is 9. So here the next is 135.135.5. So here it is up again up to 2 cells, and it will be 12 leaves. So here you can see that it will become here. These are the 12 leaves. You have to join this, and now you have to take this line downward so that you can join the same. These are the 12 leaves. So now what is next? 162, again 2 points. 162.5. These are 5 only. So here it will be only here. These are 5. Now you have to mark length up to 171 point. Again 2 cells we are taking 171.5. These are 4 in number. Here you have to mark this. This is represents, line represents 4. Now the next 2 and 180. Again we leave 2 points, 2 cells, and we mark up. This is 180 point, and the number of leaves are 2. You can mark the same. So you have so far been able to form the histogram. This is the histogram. These are all the bars which are all adjoining, and there is no space left in between. You are to here write properly in the exam. You can write it in this way, vertical way. These entries you can write in this vertical way, such like this. You can mention in this way so that all the entries are easily readable. Now the question before us is the length of 40 leaves of a plant is measured correctly to 1 millimeter and the obtained data is represented in the following table. Draw a histogram to represent the given data. We have already solved this part of the question, that is 4.1 we have already solved. Now we have to solve second and third part. What is the second part? Is there any other suitable graphical representation for the same data? If we give the answer in 2 words, that then we can say that answer is frequency polygon. Now what is frequency polygon? There may be question in the exam that what is the difference between histogram and frequency polygon. Then you will observe from the data that this was the discontinuous data, that there was difference of 1 in each class interval, which you can see that this class interval ends at 1 to 6 and the next class interval starts at 1 to 7. In the same way, there is the gap of 1 in the next class interval, that is 135 and 136 and so on. While forming the histogram, we had formed the class interval continuous. Now the question may also arise in the exam that whether in respect of frequency polygon the data has to be continuous always, or the frequency polygon can be made in respect of discontinuous class interval or continuous class interval. We will understand all these aspects. We are not to go through only through this question. We are to understand various aspects of the question, because the questions may be asked regarding that in the exam. Now we will do some rough work so that we may understand the various aspects which may be there in the examination. Now what was the given data? This was the given data in the question. Then we had formed this data continuous. Continuous means that there is no difference between the upper class limit of a class interval and the lower class limit of the next class interval, as there was difference of 1 in each class interval and we had divided it by 2, that is the result was 0.5, and we had reduced 0.5 from the lower class limit and added 0.5 to the upper class limit, and this class interval was obtained, this data was obtained. And on the basis of this data, that is this data which we had obtained after adding 0.5 or subtracting 0.5, we had formed the histogram. We will do very quickly because we have already solved this. Here we had mentioned the number of leaves. Here we had formed the kink because we are taking it as 117.5 and the next 126.5. Here we had taken the length and here the number of leaves 2, 4, 6, 8, 10, 12, and ultimately what was formed was just like that. We are only doing some rough work, and after doing all this we had formed such type of data in the form of bar graphs. This was the histogram. We are making only a rough work so that we can understand the various aspects of this question. This was the histogram where these are the bar graphs and there is no difference, no space between any two bar graphs. Now in this question it was pointed out that whether there is any other form to represent this graphical data, to represent this data graphically. The answer was yes, we can represent this data in the form of frequency polygon. What is frequency polygon? In the frequency polygon we represent the data in the form of a curve. Now whether the curve will be like this? No, the curve will be like this, that this touches the central point each of these class intervals, midpoint of each of these class intervals, that is the midpoint of this. That is, if we calculate the midpoint of these two, it will be 1 2 2. If we calculate the midpoint of this, it will be 1 3 1. If we take this point midpoint, it will be this. If we take, and so on. We will, in the case of frequency polygon, we touch the middle point of each of these, and we obtain a curve in this form, just like this. This is the frequency polygon, which forms a graphical representation of the data in the form of a curve, and the curve connects the middle point of each class interval. That is the, in between each graph, this connects. That is, it is just like that, this is connecting each of this point. So this is the frequency polygon. Now we will give the answer. Is there any suitable graphical representation for this data? The answer is, we can represent this data. This data means the data given in the question in the form of we can graphically, because there is term graphically, we can graphically represent this data in the form of frequency polygon. Now, if we restrict our answer to this point, there may be many other students in the exam which will this answer. But in this competitive world, we have to write somewhat extra to gain an edge over the other students, or we should also understand the other aspects, which we will do here. While histogram represents the data in the form of bar graphs, represent the data in the form of bar graph without any spaces between the bars. We had seen that this was the bar graph and there was no difference between these bar graphs, these bars. There, that is, we are understanding the difference between histogram and frequency polygon, because there may be question in the exam. Whereas a frequency polygon represents the data in the form of curved line. That is, it depicts the data in this form depending on the data, curved line. Now, the question may also arise, as already discussed, that whether we can form frequency polygon in respect of this data, that is the discontinuous data, or the data has to be continuous, because the histogram is to be made in respect of the continuous data. Histogram requires that the data has to be continuous class interval. That is, there has not to be difference between any class interval, no gap. The answer is that in the case of frequency polygon, it is not necessary for the data to be in continuous class intervals. That is, there is no need that the data has to be represented in this form, that the data should be in this form. There is no need. But usually or commonly, frequency polygon is used with continuous class intervals. That is, though our question was only restricted to this point that we can graphically represent this data in the form of frequency polygon, we have also understood the various other aspects, that is the difference between frequency polygon and histogram, and whether the histogram requires continuous class interval or discontinuous class interval. We have also understood whether the frequency polygon requires continuous class intervals or the data should be in the form of continuous class intervals. Now the next point of this question, is it correct to conclude that the maximum number of leaves is 153 millimeter long? This is the data which was given in the question, and this is the data which we had derived while forming the histogram. That is, this is discontinuous class interval, this is the continuous class interval, and this is the question is maximum number of leaves is 153 millimeter long. Now the maximum number of leaves lie in this class interval or in this class interval, maximum number of leaves. So we will say that no, we cannot conclude cannot conclude that maximum number of leaves are 153 millimeter long. This is wrong, factually wrong, because the maximum number of leaves because the maximum number of leaves are lying in this class interval, lying in between the length of 145 to 153, or we should also write it to 153.5 millimeter. That is, the maximum number of leaves are lying in this particular class interval. So it is quite possible that one leaf may be 145 millimeter, other is 146, then there may be two, maybe 150 in millimeter in length, but the total is 12. So this point total is represents this class interval. That is, the length may lie between anything between these two class intervals. So we hope you have understood this question from various perspectives, not restricted to what is asked in the question. Now the question before us is, the following table gives the lifetimes of 400 neon lamps. Represent the given information with the help of a histogram. Then how many lamps have a lifetime of more than 700 hours? We have already discussed that histogram, in the case of histogram, we represent the data in the form of bars, and there is no difference between the bars. Now we will start from here. Though we can directly form the histogram, it is preferred that we write something about histogram, because we have to differentiate ourselves from the other students who are also giving the answer to this question. They will be also forming histogram in the form of bars, and you will also do that. There should be something extra, that is, here you will give the definition of histogram. Histogram is the graphical representation this is the continuous data, that is, there is no difference between this to this, or this class interval to the lower class limit of the next class interval. There is no gap in between any class interval. That is, histogram is the graphical representation of continuous data. In the form of bars, and there is no gap between the bars. You can also write it that histogram is the graphical representation of continuous data in the form of bar graph. Just like we go to the market to purchase something, and there are two shopkeepers which are selling the same type of product at equal price, we will buy the product from that shopkeeper which gives something extra free. In the same way, if we do something extra while giving answer to the question, we may get some extra marks or preference in comparison to the other student who gives less explanation or simply forms the histogram. But we are giving here definition extra. So here we will form the histogram. Here we will mention lifetime. Here we have not formed kink, because we will start here from, say, 300, then it will be 400. After every 2 cells we are mentioning the same. Then here we will mention number of lamps. Then we will start from 10. We will start from 10, 20, every 2 cells we are mentioning the same, and here the maximum is 86. So we will take it up to 90, 30, 40, 50, 60, 70, 80, 90. This is x-axis, this is y-axis. Here we are mentioning number of lamps. Now, what is the purpose of kink here? Just like in the thermometer, there is a kink that the temperature may not fall. Here, the purpose of kink is that we are assuming that the lifetime is here up to this point is 300 and this point represents 100. We are assuming. So, first is lifetime in hours 300 to 400. Then the number of lamps are 14. So we can assume that it is up to this point. Next is 56. 56 lies something between this point. This is the next bar. Now the next is 60. Lifetime 500 to 600. That is this. These are 60. This is the next bar graph. Now 700, 600 to 700. These are 86. You have to draw straight line because we are not in a position to rotate the answer sheet just like in the exam you can. This is 700 to 874. 74 will lie somewhere here. Then this is 62. $800 to 900. Then 900 to 1000, the number of lamps are 48. It will lie somewhere between this point. So we have formed this histogram. You are to mention here the number of lamps in each case. It represents 14. It represents 56, 60, 86, 74, 62, then 48. We have formed the histogram where the data has been represented in the form of a bar graph and there is no gap. You can see here that there is no gap between any bar, no space in between any bar. So now we come to the next point of this question. How many lamps have a lifetime of more than 700 hours? Now we go through this data. Now the 700 is mentioned here at 2 points. Now this is the problem. What to do? Whether we should count from here or we should count from here. What to do? Lifetime of more than 700. That if we count from this, there will be many more lamps. If we count from this, the number of lamps will reduce. Now this is the convention that in case of such like of continuous data, we are not to take the data from the upper class limit, that is from this. When the something is mentioned twice, then by convention we will ignore this upper class limit and we will start from that point where this particular data or information is given in lower class limit. That is, we will start from here. For the purpose of more clarification, we can say that this data, that is the lifetime 300 to 400, it represents 300 is equal to 300 or more than 300, but up to 400, but less than 400. That is, here we will count the lamps up to only 399. Here also in the case of 600 to 700, we will take all the lengths which are equal to 600 or up to 699. That is all the lengths which have the lifetime will fall in this category. So here in this category, the lifetime is up to is equal to 600 or up to 699 hours. So any lifetime, the lamps which have a lifetime of more than 700 means that we have to start from here. Here, what is the meaning of this? That is, all the lamps which have the lifetime of 700 or more than that, or more than that. So all this data which falls in this category, here all the lamps have the lifetime of more than 700 hours. So we will calculate the total. The number of lamps having a lifetime of more than 700 hours is equal to 74 plus 62 plus 48. We will do rough work. So our answer is 184. Now the question before us is, the following table gives the distribution of students in two sections according to the marks obtained by them. Represent the marks of the students of both sections on the same graph by two frequency polygons. And next, from the two polygons, compare the performance of two sections. Now this is the data which has been given to us in the question, and we are to represent the marks on the same graph by the help of two frequency polygons. Now first point is that we should understand what is frequency polygon. Now the answer, frequency polygon is a line graph. That is, in the case of frequency polygon, we draw a curved line which frequency polygon is a line graph in which a curved line depicts the data. That is, in the case of frequency polygon, there is a curved line which may be of any shape depending on the data. Now, which point this curved line touches? This curved line connects or touches the midpoint of class intervals. That is, here if the marks are 0 to 10, it will touch the middle point, that is 5. Here it will touch the middle point, that is 15. So middle point of each class interval it will contact. So here first we will have to form the midpoint. What is the midpoint? So here we will have to first prepare the table so that we can form the midpoint. So these are the marks Marks in case of both the sections fall in the range of 0 to 10, 10 to 20. So here in the same way we will write marks 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. Here we will draw lines so that our information may not get mixed up with other columns. So here we will calculate the midpoint, or it is also known as class marks or midpoint. How the midpoint is calculated? We will total the lower class limit and the upper class limit total and divide it by 2. We will total lower class limit and upper class limit divided by 2, lower class limit, upper class limit divided by 2, lower class limit plus upper class limit divided by 2. In the same way this. So what we find here, we will arrive at 5, 10, 20, 30, 30 divided by 2, 15, 20 plus 30, 50 divided by 2, 25. Here 70 divided by 2, 35. 40 plus 50, 90 divided by 2, 45. So we have arrived at the midpoint, that is 5, 15. Now here we will write frequency. Section A, section B, frequency. What is the frequency A? In the case of A, it is 3, 9, 17, 12, 9, 5, 19, 15, 10, 11. So what we have done so far? Firstly, we have understood the meaning of frequency polygon, that it is a line graph where the curved line depicts the data. And how the curved line is formed? The curved line connects the midpoint of the each class interval. So now we will form the two frequency polygons on the basis of this data, this table which we have formed. Now we have arrived at midpoint of each class interval. Now using this information which we have arrived at, we will form the two frequency polygons on the same graph. This is the graph, we will use it. You have to draw straight lines. Now this is x-axis, as you know. This is y-axis. Now you will draw here the, on y-axis you will draw frequency, or frequency means the number of students. On the other hand, you will draw the class marks or midpoints. So now what is the frequency? It's the lowest is 1 and the maximum is 19. So here we will start from 2. For every 2 cells, after every 2 cells we are marking it 2, 4, 6, 8, 10, 12. Any marking on the graph should be made keeping in view what is given in the data. That is, here we have considered the lower frequency and the highest frequency, and on the basis of the same we are marking this so that we can show the same on the graph. Now We have drawn the frequency here. Now here we will draw the class marks. The maximum are 45. Now we will start from here. After every 3 cells, we are marking 5. 5, 10, 15, 20, 25, 30, 35, 40. This is 45. Now this is the maximum class marks. So now what is class marks? It is 5. And what is the frequency of section A? In the case of section A, it is 3. And in the case of class marks 15, it is 9. You can say here that it is this point. Now at class marks 25, no, this was taken as wrongly taken as at this point. This is not to be taken at this point. At point class marks 5, frequency is 3 in respect of section A, and at point class marks 15, it is 9. Here we are to mention 9. This is, and next at 25, that is this, it is 17. It is somewhere here. This is 17. Now at class marks 35, that is this, it is 12. It is here, 12. Now at class marks 45, it is 9. It is here. So we will draw this, join this, that is the curved line, that is the frequency polygon in respect of section A has been formed. Here again we are not joined properly. Now in respect of section B, frequency at 5 is 5. So here the frequency is 5. This is the section A. We will write it. This is class marks 15. It is 19. 15. It is 19. It is somewhere here. Now the next point is we can join the same so that there is no confusion. At class marks 25, that is this point, this is 15. That is, it is somewhere here. We will join it. Next at point 35, it is 10. 35, it is 10. Now at point 45, it is 1. Somewhere here. Now this is the frequency of section B, and this is the frequency of section A. Now you will see that we have formed the frequency polygon, that is the curved line graph, separately for section A and section B. Now what is the next point in this question? From the two polygons, compare the performance of two sections. We revert to this point slide. You can see what is the question. From compare the performance of two. From the graph, we will write the answer here. From the graph, we can conclude. You can see here that the number of students of section A are in a position or have obtained more marks as compared to section B. So we can conclude that even if you see the data, you can see that the number of marks which are on the higher side have been obtained by section A. You can also see from this. So while writing the answer, we will write that from the graph. You can see here that the graph, these lines are on the upper hand in respect of 3 points. This one on 3 occasions. This is, and in respect of only 2 points, that is this and this. That is when the class marks was only 5 and 15. The section B was ahead. But in respect of the 3 points, that is the class, when the class marks were 25, 35 and 45, the frequency in respect of section A was more. So we conclude that the students of section A performed better than section B. Now there is another point which we should also mention here, that when we are drawing the frequency polygon, that is this curved line, there is no need, it is not necessary to find out where frequency is 0. That is, we need not to find out where the class marks are 0 or where the frequency this is 0. We are not to take into this quantity. It is not necessary. Thanks for watching. If you like our course, please spare some time to give a star rating to our course.